Welcome to this Broadcom video on the integration between AAI and Broadcom's CA7. This is the overview. In this video, we outline the integration of AAI and CA7, called CA7 Server for AAI. It makes it possible to extract data from CA7 and make it available to the AAI server so it can process and then build its own database. From this point forward, we'll refer to CA7 Server for AAI simply as the software and its individual instances. The software makes two types of data available to the AAI server: operations data called events and definitions. We provide high-level details of the installation, preparation, and implementation. We describe an instance architecture, steps in the installation and deployment procedures. We want to make sure that technical concepts around datasets, libraries, and file system are completely understood. By the end of this video, we should know how to start the software's ISPF-based user interface. This is the architecture. We start with two systems, ZOS and the AAI host. When installed, the software creates items in both USS and in AZOS-D. The basic configuration has ZOS libraries installed once and shared by all instances of the software. Although it's possible to install the full package for each instance, we will not cover this, but it's documented. At the core of the instance, we find the server STC, which is the process running continuously in the USS environment. This is the software server. Its purpose is to generate two sets of files, events and definitions, which are generated in a directory in a mounted ZFS file system, for transmission to the AAI host via FTP or SFTP. At each polling cycle, say 30 seconds, the server STC generates a file called RPT70, with the date and timestamps appended to its name. The CA7-8 utility does this. The data is acquired from CA7's logs to build a file RPT70, which contains events. RPT70 is generated directly in a directory, which we set during instance configuration in the ZFS mounted at IPL. RPT70 is then sent to AAI via FTP or SFTP. When the transfer completes, a dataset called SRVR-CKPT, the checkpoint dataset, is updated with the date and timestamps of the send, in the event recovery is needed. The default acquisition cycle for events is set to 30 seconds to guarantee proper syncing of CA7 and AAI. Definition data is static, which means very low acquisition cycles. The secondary purpose of server STC is to spawn a child process in USS that uses a CA7 API called CCI term to generate 4 definition files: LDSN for dataset dependency definitions, LJOB for job definitions, SCAL for calendars, and timezone, which stores the CA7 timezone. Just like RPT70, these files are generated in the ZFS directory and then sent by FTP or SFTP. Polling cycles are set to once a day by default. The initial server STC start is executed with an instance-specific JCL. This invokes BPX batch to start the Unix environment and then passes a Unix executable as a parameter. This executable, called AIS7 SRVR, is the server STC code. We have additional elements. The software contains an ISPF-based user interface called IMS, or Instance Manager System. IMS handles the management of software instances. It relies on a library called custlib that contains the JCLs and clists needed to administer via IMS. IMS can support multiple instances of the software. This means we can deploy more than one software instance in a given LPAR or across multiple LPARs. IMS makes it possible to manage all instances through a single interface. When a software instance is configured, settings are stored in an instance-specific dataset called SRVR-SCFG. Finally, we have a second STC called Request STC for the shutting down of the server STC. Shutdown can also be initiated via IMS. SRVR-SREC is a dataset that contains one of various 4-character codes. Open means server STC is not currently processing and is ready to accept new commands. Another is CLSD for closed, meaning server STC is unable to process new commands. Both request STC and shutdown initiated IMS. Check that SRVR-SREC contains open and overwrite with the term code to instruct it to shut down. Once this happens, the STC writes the code CLSD for closed. Other possible codes include those associated with definition data requests, like ADEF or JDEF. ZOS libraries are installed once and shared by all instances. However, deploying to a different LPAR requires a new instance, but only the Unix components. For this reason, the installer will provide two options: either full install USS and ZOS, or USS only. Let's go over some of the terminology. Server STC is a USS-started task that runs the software processes. It is started by a JCL, which invokes bpx batch and passes the server code Unix executable as a parameter. It has three functions. First, it generates the events file RPT70 on a very short cycle, say 30 seconds. It leverages a CA7 utility called CA7 to generate the file. Second, it spawns a USS child process on a very low cycle, say once or twice a day, which invokes a CA7 API called CCI term. Third, it triggers FTP or SFTP. Request STC is a transient process that handles the shutdown of the server STC. It does so by issuing a term request to the primary server. SRVR SREC is then updated with the CLSD code. The process starts, issues the code to the dataset, and then finishes. RPT70 is the file that contains all the CA7 events for a specific time span, say the last 2 minutes. It is built by ways of a CA7 utility called CA7. A ZFS file system is mounted in USS at initial program load. This ZFS stores the acquisition data, events, and definitions for AAI. RPT70 is generated in ZFS for FTP or SFTP transmission to AAI. There are 4 definition files delivered to AAI for it to populate its own database. LDSN, which contains dataset definitions needed to model CA7 dataset dependencies. LJOB, which are the job definitions. SCAL, which contains calendars, and timezone, which contains the time zone value where the instance of CA7 is executing. These 4 files are generated in the ZFS using the CCI term CA7 API. IMS, or Instance Management System, is an ISPF interactive menu that administrators use to manage their software instances. We can add new instances, update, manage, trigger a shutdown, and much more. CustLib is the ZOS library that contains all the JCLs and clists necessary to manage IMS and the instances. Since IMS is common to all instances, CustLib lives on the ZOS-D. When an instance is created, a JCL is generated. We execute this JCL to start the server STC. It invokes bpx batch, which initiates the USS environment, then passes a Unix executable as a parameter, AIS7 SRVR, which is the software server code. SRVR SCFG is a dataset that stores instance configuration data. Each instance has its own config dataset, in which we'll find the instance's name, source CA7 server, destination AAI server, file transfer methods, data acquisition cycles, and more. SRVR SREC is the dataset in the instance that reflects the state of server STC. When the STC is active but not processing, the dataset contains the code open, indicating it's available for new processing. When the STC is brought down, the dataset contains the code CLSD. Let's outline the procedure for installing and configuring CA7 Server for AAI. First, we perform all initial preparations. A few things are required. We need the Rex library made available to all LPARs where at least one instance will be created. A product directory is needed in USS to install the Unix files, and a few more things. Then we download the install package. This is a zip file which we unzip and upload to the mainframe. The package should have the pax.z extension. We start USS in the LPAR we want to deploy to and copy it in a temporary directory. The package is a pax file, and so we use the pax command to unpackage the file. Finally, we start the installer. The installer presents 2 options. We can either perform a full installation, which installs both ZOS and Unix components, or the USS module deployment only. We then execute the cust-lib clist member AIT-cprim to start the IMS UI. IMS is our main user interface. It makes it possible for us to create new software instances, configure or update an instance, and so on. We're given a choice between CA7 or IBM's IWS for z/OS, and so we select CA7. We create a new instance, set basic aspects like HLQ, LPAR and colors, and allocate datasets. Then we configure the instance, the CA7 server it's sourcing from, the AAI server it's sending to, and the software itself. The ZFS needs to be mounted at IPL. For this, we use a JCL that we add to BPX PRM XX member in sys1.parmlib, which is generated once the instance is configured. We add the server STC to the z/OS automation services, start it, and check that the data files are being delivered to the AAI host. Finally, in the AAI web UI, we add the CA7 scheduler so that AAI is able to consume those data files. Let's consider some deployment scenarios and the impact on the instances. We have a mainframe with two LPARs. The first LPAR has two instances of CA7, while the second has a single CA7. We also have two AAI servers. Each CA7 instance needs its own software, and an instance of the software can only communicate with a single AAI host. Multiple instances of the software can send data to the same AAI server, but a single software instance cannot send data to multiple AAI hosts. So we could support a setup with 3 CA7 instances, each having a dedicated software instance. Instances 1 and 3 report to AAI host 1. Instance 2 reports to AAI host 2. This is possible. Let's consider what's not possible. You cannot have a single instance of the software acquiring data for more than one CA7 instance, irrespective of the number of AAI hosts. A software instance is always mapped to a single CA7 instance. Further, you cannot have a single instance of the software reporting to multiple AAI hosts, irrespective of CA7 instances. A software instance always reports to a single AAI host. This is the navigation map. We start with the installer, which we execute in USS with /AISZ_installer. This initiates a menu with two options. Either USS modules only, which we use when the software has already been installed and we're targeting a new LPAR, or full install, which we select if it's a first install. This installs both the Unix components, but also the z/OS libraries common to all LPARs. Once installed, we execute the AIZCprim clist in the custlib library, which starts IMS. IMS gives us two options, either IWS or CA7, which we select. In the Instance Manager menu, we have four options: A for Add, C for Configure, U for Update, and M for Request menu. Adding has a sequence of two screens. The first captures the name of the LPAR automatically. You also enter the AAI and CA7 instance IDs and set a color theme. The second menu contains the dataset allocation functions, sizing, and so forth. It will also prompt you for the high-level qualifier, which will serve as the base HLQ for your install. Configuring means entering the AAI host settings, which we deliver data to, the CA7 instance, which we acquire data from, and the software itself. This is where we'll set the data acquisition polling cycles. In the Update menu, we can make alterations to the configuration. Change HLQs, rename the way the LPAR appears in our interfaces, and regenerate JCLs in the event we change the HLQ. Finally, in the Instance Request menu, we can access the software log, trigger a manual dump of the definition data, and ignore the last checkpoint after a warm recovery and reacquiring of the data. We can also shut down the instance. These are the elements you should download from the Broadcom site in order to perform the installation. You obtain the main AAI installer package that contains all the elements, AAI files, connectors, and so forth. In the Connectors folder, look for a zip file identifiable as applicable to the mainframe. The current version is labeled Data Provider. In this file, you'll find a pax.z file, which contains a number of files, such as the AISZ_installer file, which is the installer. Thank you. This concludes the video.